My name is David Cardella. I'm the product manager for our developer technologies, which span a few of them, certainly the native Runtime SDKs. I'm joined here by our CTO of our developer technologies, Ewan Cameron. Thank you, Ewan. So Ewan and I work very closely together across all of the APIs. We have a special affinity, though, for our Runtime SDKs. How many folks currently develop using one of our APIs at one of the versions? Okay, good. How many of you have apps or are still developing upon the 10.2x series of releases? 10.2x? Okay. And how many have already either started the migration or you've started a new project and you're currently using 100.x? Okay, a few.
What about engine developers? Any engine developers here? Okay, good.
Okay.
What about JavaScript developers who want to build native apps? All right, okay. Got a nice mixture.
Yeah. What about cross-platform? Who needs cross-platform? Okay. Okay, yeah, we've got a good mixture. So I think what we're going to do today is thank you, Ewan. We're going to talk about this session is all about an introduction to the runtime. It's about finding out what we offer. I'm going to talk a little bit about the developer experience, what our technology can do for you, where people find that information out, how they get started. Some of you may already say, well, wait a minute, we just told you I'm already started. Actually, a lot of the resources that I'm going to show aren't just for new folks coming in looking to get started. They're for you as well, and I'll talk about the value that I see for you. Then I'm going to hand it over to Ewan, and Ewan is going to dive in deeper into the architecture, not only of the runtime, but also our thinking about the new generation of releases, the 100 series, why we made that decision, some of the main differences, so those folks looking currently on 10.2x looking to migrate over or upgrade to 100.x will get good information from that, and then we'll end it with a quick licensing discussion. Okay. See that, Ewan? I've already. Oh, there. Oh, gee. Okay. So the developer experience. It's when we release APIs, we don't just throw them over the wall and expect not only you but our internal teams to be successful with them. We need to provide you with a good SDK, so it's the supporting resources, documentation, samples, etc. But it's also providing a great developer experience as a whole, and that experience starts with the developer site, and that's what you're looking at now. We recently redesigned this landing page. We wanted to redesign it to allow you, existing users who may already be using the runtime or another developer technology, as well as new users, to find what they need really quickly and go there. So the way that we did that was we tried to answer, for the newer users, we tried to answer two questions. What can your technology or developer APIs do for me? And then how do I get started? And so to help answer the first question, we have redesigned all of our feature pages. For those of you who have seen our feature pages before, you'll notice the big difference. Here is our directions feature page. We talk about all the options up front. You can take data offline, you can create your own network data sets, you can use our SaaS-based service. And then on each of the feature pages, we've provided for you samples. Most of these are all live samples, and I say most of them because our strategy is that they are all live. Most of them are live right now. So of course we can generate optimal routes and generate directions for one or many places, but because everything sits on top of the ArcGIS platform, we leverage that power, and we can do a lot more. Here's one that calculates drive times, and so I showed this in the plenary. We can change some of the inputs here and see how see how that affects the map. Here we'll change from driving to walking, and we can see that. At any time, I can either link out to the dev labs to see how this sample was written, or we link into our SDK documentation to discuss the capabilities you see here. That's kind of a little teaser to dev labs, but I wanted to make that point. Of course, routing to the closest facility. Now this sample is very straightforward. Each time I run the sample, we're just generating random locations, and then we're finding the closest one and then routing optimally to that. Another fairly popular feature or set of features are all of the analysis tools that we expose. So we talk about leveraging analysis using our desktop workflow, but also our services. And all of these live samples here use the analysis that we expose through our services. Here's one that talks about aggregating and normalizing data. This one is pretty interesting. This allows someone to specify an area of interest using the square you see here, drag it over a set of data, and then extract that data and use it in some way. I mentioned that for these live samples, we link out to either a dev lab where you can go through it and accomplish those tasks yourself, or in this case, the SDK documentation. Some of the other things, actually this is one of my favorites, pattern analysis. So we use hotspot analysis just to look at patterns that might be there in our data. And I think this type of capability gets overlooked at times. Of course, we can perform a litany of geometry operations. I like this sample because it's very simple, and I think it represents a lot of what folks want to do, at least initially in their applications when they're thinking about analysis. Here we're simply buffering the path of a hurricane. We're performing a simple intersection to determine where it's hit landfall. So that's one way in which we are attempting to answer what our technology can do. The other way is actually through you, through our customers, through the voice of our customers. I, for one, think that is a very powerful way to communicate what our technology can do. It's one thing for Ewan and myself to explain to someone, oh, well, we can do A, we can do B, we can do a lot of things. But if we actually have successful users like yourself explaining that same thing, it almost becomes more real to another user. And your voice we call success stories. So all of the success stories are categorized by industry. Here's an interesting one here. It's built for mobile devices, and it's called GoTime. It's released by Massachusetts DOT. And so if you've been driving on at least the US freeways, there are certain signs there where it gives you a time to a major junction, a major city or location, so that you can get an idea of what traffic is like. Well, all of these signs are now provided in an application. You don't actually have to physically be there to see it, and they've also integrated traffic information, so it's all right there. I really like this success story here. This is an application called Command X, built by a partner of ours, and it helps tactical teams, tactical units make smart decisions in an event of an emergency. And the reason why I really liked this one is it's a good example of them really embracing the web GIS pattern. So Ewan's going to talk a little bit about this, but our runtime APIs have fully embraced the web GIS. This means that the web map and the web scene are the central component of all of our native APIs, and actually really all of our APIs that we provide. And so what Eurocommand has done is, rather than build an app that accesses these services directly, they've built an app that accesses web maps. So they have a number of web maps that they've authored, and they've built the app. And so they've noticed a lot of advantages with this. They write less code. So when you have an app that accesses services directly, you're writing code to access all of the information about that service, rendering information, pop-up information, any other capabilities that are exposed by that service. But when you use a web map, just in a couple lines, literally a couple lines of code, maybe 3, you could get at all that information, and it's just hydrated to you within the API that you're using. By using maps, there are some app updates that can be recognized by end users. End users who are simply editing existing maps can edit the map, not only see the changes in the application, but if, depending on what's authored into the map, the application you provide, and certainly it's the case here with Command X, changes based on what the web map has. For example, if bookmarks are authored within the web map, then the capability to look at and go to these bookmarks is enabled and visible within the application. If there are no bookmarks, it's okay. So the UI doesn't need to expose that capability. The other good thing that I like about this sample is that they're leveraging ArcGIS identity as well. So these web maps and the items that are in these web maps are all shared through a portal, and they're using ArcGIS identity to not only access those items but also license their application. We'll talk about licensing in a moment. So those are a couple of ways in which we're trying to get the word out about what our technology does. And so I guess the next pertinent question is, great, you've shown me what we can do, you've hopefully have gotten you excited. What next? How do I get started? Getting started is easy. You just sign up for the developer program. It just takes a few minutes. You don't even have to open your wallet. When you join and you become a member, you get access to a number of these things you see here. Who has joined the program? I assume most of us here. If not, you're probably new, so this might be of interest to you, so you want to find out how to get started. Of course, access to documentation, conceptual API, reference documentation, all of our client APIs, our JavaScript API, our Python API, and of course our Runtime SDKs. You also have access to a large developer community that you can communicate with. That's great. Once you've signed up, you really want to get a little bit of a kickstart. We have 2 very good resources that can help you get started. DevLabs and Example Apps. Who has tried our DevLabs? Show of hands. A couple of folks. Good. So DevLabs, there are 3 different types of DevLabs. There's data DevLabs that involve going through the data preparation process, whether it's bringing in data from a CSV, publishing. They go through publishing data through our platform. Design DevLabs are all about designing your map, not only how your map looks and how it's rendered, but also what user experience is going to be there once a user interacts with your map. So it's about designing pop-ups as well. The design DevLabs also include authoring and styling any vector base maps that you may have, vector tiles. The developing DevLabs are all about that, developing. And so these DevLabs take you through very short lessons, little vignettes on how to accomplish a specific task. So these aren't full-blown applications. Each DevLab gives you some information as to the duration. So this one is specifically 10 minutes. There are no DevLabs over 15 minutes. We've done that on purpose. We know your time is very valuable, and so we wanted to make them as succinct and as focused as possible. And on that note about your time being valuable, if at any time you wanted to just skip to the solution and see what it looks like live, we have that available to you as well. So I also mentioned earlier in the week that last year at this time is really when we kicked off the DevLabs at this event, and I think we had a handful, maybe 5 or 6 you, and it was sparse to say the least. Now we're well over 100 DevLabs. We have our team that's responsible for this. They organize DevLab days where it's a full day-long workshop where we invite folks, not only from within our team, but from around the company who use our native APIs to come. And the day is all about developing new DevLabs that we can put on the site. So that's been very successful. But because there's so many, we needed to provide a way for you to filter and get through these DevLabs. And so we provided some filtering capability. You can filter based on functional or topic or capability itself. Of course, a lot of developers identify themselves by the API they use, the platform they build for, etc. So we allow you to filter on that. And then in order to determine or see some of the new DevLabs that we've just added, we allow you to filter on that as well. So those are DevLabs. Another great way to get started are example apps. So anyone play with and have used our example apps before? A couple folks. Okay, sort of. All right. DevLabs are pretty cool. They're full-blown applications built by our team. We provide the source code for you in GitHub, but we give you a lot more than that. We give you very detailed and deep documentation on the application itself. So we have this documentation. It's tutorial in style in that we go through major blocks of code in the application. We explain why we've written that code, what's going on behind the scenes, and why it's important for that application. So we take you through the mindset and the process that we use to build this application. So example apps really have a lot of benefits, but the two main ones are we do illustrate best practices, and we also provide a kickstart, hopefully, to your application development. So you can start with one of these apps if you see functionality that is in line with the type of solution that you want to build. You can keep the capabilities that you like in there. You can rip out the ones that you don't, and then anything that you don't have, you can implement. So those are example apps. So between DevLabs and example apps, we've really provided a pretty strong starting point for anyone. I mentioned starting point. It's a little misleading because both of those resources are also pertinent to yourselves. Folks who a lot of you said that you are already working with the runtime. For those of you on the 10X looking to come over, you'll get a look at a lot of the code that's used in the 100 series. So these DevLabs and example apps are a great way for you to get started. Many of you are native developers, but you may be a .NET developer looking to get more into iOS. These are great resources for you. And then, of course, web developers who are looking to come over and use some of our native APIs, it's also a good resource. So once you are working with our APIs, chances are you're not going to visit at least the capabilities page too often. You'll probably want to see what kind of success stories are out there, and of course those DevLabs and example apps are always good resources, but chances are you're going to bookmark and go to the API that you're working with. Each of our APIs has, we just call it the API homepage. Here's one for iOS. So we go through some of the main patterns when developing iOS apps. We do talk about our previous versions, and we give you information and guidance on choosing the right version, as well as also choosing the right API itself. Each of the home pages has, of course, links out to documentation, the reference guide, all of the sample code. You can link out to GeoNet, where all of our forums are and where all the conversation is happening. Here's the sample code page for iOS. The reason why I go to this, actually, is because we have released an application that, what number am I? Is it 3? Yeah, I think it's 3. So here I'm on my iPad. We have an application in the Apple App Store that contains all of our samples. And so the reason why I really like this is if you wanted to show either other stakeholders in your company or perhaps prospective clients some of the capabilities that you can build for them. You don't have to quickly throw together a prototype. You can simply, well, compile one of our example apps or download this app and show them some vignettes of capabilities. So we categorize them. Here's an interesting one called Show Magnifier. We've received a lot of over the years, since we released Collector, we received a lot of requests as to how we implemented this. This simply, when you long press on the map, gives you a magnifier. Not so much to magnify the data so you can see it. You can zoom in for that. This is very good data. But if you wanted to drop a point in a data collection scenario or anything like that, that's the same mechanism that Collector uses. We can do routing and directions. Let's route between a few places here. Great. We can get at, of course, the directions for that. If I wanted to add a barrier, let's go ahead and add a barrier. Let's reroute. We can see how that route has changed around that barrier. And so we provide this application for you, so you don't have to build your prototypes. It's there at your fingertips. The other thing that's there at your fingertips are an explanation of how it works and some of the packages that we've used, but also all of the source code is available to you within this application as well. So that's pretty valuable. So that's just kind of a quick whistle-stop tour about the developer experience, how folks can get started and find out more information about our APIs.
Thanks, David. All right, so we're going to change gears a little bit and start to kind of dig into the architecture of the runtime. And when we're putting the slides together, it's really trying to serve numerous audiences. It's here to just educate brand new people to the runtime and the architecture and some of the basics in the API. It's here to help existing runtime users on 10.2x versions migrate their thinking over towards the newer releases. But it's also useful if you're an ArcObjects developer and you're thinking about getting into the runtime for the very first time, and a JavaScript developer. So what I'll try and do is, if there's an analogy in an existing sort of developer technology, I'll try to bring that across to help you understand things. So with the version 100, which was released a year past December, it was formerly codenamed Quartz, we released a brand new runtime architecture. And we did that for a number of reasons, and a number of benefits come out of that. We'll go into details of what these were. And along with the new architecture, we have a completely new API, which was released about a year and a bit ago. And we've had 2 more releases since then, 100.1 and 100.2. Actually, we'd had a very small 100.2.1 release just last month. But we're basically on a cadence now of every 6 months, in June, just before the user conference, and then in December, just before the end of the year, we're shipping versions of the runtime. There was a bit of a pause in our release schedule because we were working on this overhaul of the architecture. We didn't have a regular set of releases, but now we're on top of the new architecture. Moving forward, you will see a very constant, every 6 months or so, you'll get new capabilities coming into the runtime. So on top of the new architecture, we wanted to redesign our API. So a little bit of history on how the runtime started. We had a group of Windows developers who were looking at what would the ideal .NET API be if we were creating one from sort of the ground up, a fresh start, to move away from ArcObjects, because as you know, ArcObjects is a COM-based API, and it does have .NET bindings, but you're still a COM programmer just using C#. You're not a .NET programmer using all the facilities of the language, because you're kind of locked into the COM way of doing things. So the .NET team started to build out an API, which became the WPF API at the time, Well, about 10 years ago, we all know the iPhone got launched. And so a group of developers thought it would be kind of cool to have an SDK for putting maps on the iPhone, because there was no maps on the iPhone at the time. And so that group of developers started. Well, because a group of developers started doing that, another group of developers thought it would be really good to have an Android SDK as well. So they started working on it. And after about 3 or 4 years, we did release all of this developer technology, and it was all under the banner of Runtime, because it was for native application development. But the truth was, it was all built on top of its own stack of software. And that meant writing the lowest level code all the way up to producing the API. And ultimately, we had every team was an API design team. So guess what? We had different looking APIs because different people were doing the designs. Each team got to choose what functions they would add into their API. So the bad thing was every API had a slightly different set of functionality. And that proved very challenging for you, because you would do something on iOS and you would want to do the same thing on Android. Sometimes you just couldn't because the functionality wasn't there. Or if you could do it, it was done in a very different way, which is less than ideal. For us at Esri, while that was a terrible story for our external developers and we wanted to change it, it was also not a sustainable development pattern for us, trying to replicate all of this capability on all these different platforms with a limited set of resources. So we started the Quartz project about 4.5 years ago to come up with a brand new architecture. And that's based more around a core C++ code base, where almost all of our business logic is implemented once in C++, and then it's exposed out through the appropriate APIs. And we'll get into the details of that architecture in a bit. But because we were overhauling the internal architecture, we also felt it was right for us to completely overhaul the API. We'd learned a lot from building our APIs in these different environments, Android, iOS, Windows, etc. We wanted to learn from all of that, plus what we'd learned from ArcObjects, and we wanted to do it in a consistent way so that things were very consistent, conceptually at least, across all of our different SDKs. They don't look exactly the same, the APIs, because the .NET API looks like a .NET API. The Android Java API looks like an Android Java API, but conceptually, they're the same. So the functionality, the goal is to always have the same set of functions and same capabilities across all of our different native developer technology. So the reasons for doing the API redesign, it was a great opportunity for us because we were having to redo everything anyway because of this new architecture. Let's design things the way we really want to design things. Also, let's design things to allow us to grow the architecture and grow the API in a sensible way. So predicting more what's happening in the future rather than just living in the moment. And so you'll see a number of places in the API that you might look at it and go, that's a bit odd. Geometry is a case in point. Why have they done this? Oh, but there's curves coming. So we've allowed space in our API to add capabilities without it being an obvious bolt-on. It's just a seamless piece of the API. So we've done a lot of design work up front. Even though we don't have the implementation ready yet, we'll be able to plug that implementation in and the API will grow nicely. The other thing that we wanted to improve was the ease of use and making it very consistent. So if a section of an API behaves a certain way, then another piece of the API that has similar sort of programming paradigms should behave exactly the same way. And so we've added a lot of consistency. We've added some standard patterns, like the loadable pattern for dealing with loading asynchronous resources. There's one way that we work with asynchronous resources. It's through the loadable pattern. And every place where you see a resource being loaded asynchronously, it always follows the loadable pattern. So it's very predictable. Once you've learned the loadable pattern for dealing with layers or maps, you know how to deal with the loadable pattern for another aspect of the API. The other thing was that just by changing how the API appears, we can actually improve the performance of the internal engine of the runtime, that C++ core. If we know that some objects are never going to change because they're immutable, that allows us to optimize things internally. On the other hand, if we allow immutability in some objects, we've always got to protect them. We've got to make sure that we're always checking to see if somebody's changed it before we use it, and it slows things down with lots and lots of checking code. And so by being judicious on our mutable and immutable objects, we've been able to improve the performance of the core. So it's all based on what we refer to as this Runtime Common API. We have this common conceptual model across all of our platforms. We try very hard keeping the capabilities the same, where there are some platforms have more capabilities than others, but that's more based on a platform restriction rather than the team just didn't have time to implement it type thing. The names and the parameters, lots of thought goes into the naming of our objects and class names, etc. And these will be the same. If a class has 5 overloads on a certain method, that method on every API will have 5 overloads, and they'll be the same overloads in the same order, etc. So they're very consistent that way. But as I said before, it's not one generic API for everybody. We do take that, if you like, that common conceptual model, and we do localize it for the appropriate developer technology that it's being used within. So a summary of the big changes that we put in, and we'll go into most of these in a lot more depth, excuse me, with the 100 release. We got a new internal architecture. We moved to a reference-based semantics. So all of our objects, there's one exception to that, but all of our objects are reference-based. So you can do the classic map.layer. Type thing. And once you get the end object with the property, you can just change that property, and because they're all reference-based, that's all you need to do. You don't need to set it back. In the 10.2x runtime, some APIs were reference-based. .NET was one of them. Other APIs were value-based. Qt was one that was value-based. If you're an ArcObjects developer, you got the worst of both worlds. ArcObjects is reference-based and value-based, and you never really knew when it was one or the other. Trial and error was the name of the game there. Sometimes you could get an object from a property, change its properties, and that's all you had to do. Other times you would get an object, change its properties, and you then have to set that object back on the class before the changes took effect. And that type of API design is not great. It's not consistent. It's not predictable. It makes it very hard to learn. And so we wanted to get very explicit about our reference semantics. We've got a huge number of changes in the mapping API. This is the one section that really got completely overhauled. We introduced the concept of a map, which seems crazy now that we didn't have it before. But we didn't, in the runtime before in 10.2x, have this notion of a map. We had this notion of, if you like, a map control and layers, but there was nothing more than that. And because we're now embracing, as David said, the web GIS pattern, where a map is a pretty fundamental concept there, the web map, we wanted to embrace that map as well. And so now we have the map. It's a central component of the object model. And you can easily create maps from code. You can open maps from the web. You can open maps from Pro in the form of map packages or mobile map packages. And you work with maps. If you write your code in your application to use a map, then your users can easily interact with other users by sharing maps. And so your application automatically becomes interoperable with the Esri applications, because they work with maps as well. So it's something that we really wanted to promote. We got rid of extent as a way of setting what the user's looking at, and we introduced this concept of a viewpoint. A viewpoint works in both 2D and 3D. And this is an example of where, even before we had 3D released in the API or designed, we knew it was coming, so we wanted to accommodate 3D in our object model. So we added a viewpoint capable of 3D functionality when it eventually rolled in, which it did earlier last year for all the APIs. The other thing that we got rid of was a graphics layer, because layers belong to maps. Graphic layers don't exist in the web map, and so there was no such thing as a graphics layer. Graphics typically are application items. You perform a search, and you want to put a push pin in the map temporarily as part of your application logic. Well, you do that now with a graphics overlay, and graphics overlays always sit on top of the map, and so you use graphic overlays. But we wanted to make that very explicit call. So things within a map are persistable within a map document, and then you can take that map document and you can share it with other users. We changed some of the layer names, the class names, to better represent where they are in the layer hierarchy, and to better represent what they're actually displaying when they're rendered. And we made changes to the symbology model to accommodate advanced symbology. So within ArcGIS, there's actually numerous symbology models, but it boils down to two. In simplistic terms, there's the web symbology model, which the JavaScript API uses. It's quite simplistic, but still quite powerful. And then there's the advanced, what we refer to as the cartographic information model, which is what the desktop uses. And that's what Runtime uses as well, natively. But to accommodate both, we had to modify the symbology model. And you'll start to see through the course of 2018 a number of API enhancements coming to the runtime that bring more and more and more advanced symbology features to you as developers. And so Runtime is capable of displaying a web map that the JavaScript application has authored, and that uses simple symbology. It's also capable of displaying a mobile map, which has been authored in Pro, which has advanced, much more powerful cartographic capabilities there. But within the object model, we need to expose it to you as developers in a meaningful way. We can't mush them all together in one symbology model, so there's two representations there. The Geometry API got a significant overhaul. We'll go into the details of that in a future slide. The Portal API is something that really got promoted because working with your portal, working with the geoinformation model is now fundamental to the applications that you build. You want to work with groups and users, layers, maps, scenes, so that these have all been promoted as really first-class citizens within the API. It's not just a REST request that you make and you get back a payload of JSON that you have to manually parse. They all come to life in a nice object model. And authentication was an area that we had got feedback from users and developers in usability testing that it's incredibly complicated to get authentication right. And it is really important to get authentication right, not just to make sure you can connect to the services that you want to connect to, but you do it in the proper secure way. And there's, as you all know, there's lots of ways that you can connect and authenticate with the ArcGIS system. You can use OAuth sometimes. You can use token-based authentication sometimes. Some servers require authentication, some servers don't. And so to try and simplify that, we created a new component called the Authentication Manager, which has a lot of built-in behavior. And if you're happy with the built-in behavior, there's really nothing for you to do. You can simply use the Authentication Manager. It has default user experience that pops up and takes care of things. But we do allow you to layer in your own user experience if you don't want ours. But still, the Authentication Manager's business logic will kick in, and it's greatly simplified connecting to secure services. And of course, we had to introduce 3D. So we'll go into these in more detail later. But first of all, I thought it would be fun to have a look at the architecture of the runtime. So this is our C++ runtime core. Excuse me. And this is the way that it was built for 10.2x. So we built it on 3 computing architectures. We use DirectX and OpenGL for our rendering and some of our analysis functions. It is exposed on these platforms, and then we have these APIs that sit on top of it. And the whole thing is generally referred to as, that's the ArcGIS runtime. When we talk about the ArcGIS runtime as a company, we really talk about all of that. And but that's not really telling you exactly how it works internally. And this was a story that we would tell for 10.2x. It's also a story that works for the very latest. At the highest level, it's the same story. We try and put as much as we can in C++, and then we have these separate APIs on top. But the reality of it, this is how it worked at 10.2x. We had our runtime core, and we had a thick interop layer that was handcrafted by the different teams, which would expose they would choose which functions to expose from the runtime core. They would choose how the API looked, the design of the API. It was all encapsulated in that handwritten code, and that was expensive to write, expensive to maintain, had bugs in it. Often the same bug would appear in everybody's API, and it was just very inefficient. So that's when we started with our effort to come up with our new architecture, which we now have. It's still based on C++, and we implement, all of our subsystems are implemented in C++. We have, sitting on top of these independent subsystems, a unified C++ API, which actually looks, to all intensive purposes, like the public APIs that you work with. It has the same concepts. It offers a lot of the same functionality, and we spend a lot of time designing that API. We then take that beautiful C++ API and we smash it down into a straight C API, because we want binary sort of compatibility, but we also want binary separation from everything above us. And that binary separation is important because when you put the public APIs on top, the public APIs, they're all using different compiler technology. Sometimes there's automatic separation that we get from, say, .NET down into the runtime core. Sometimes there isn't a separation in the compiler technology unless we explicitly want it. For instance, Qt, iOS, they're using the same C++ compilers to compile their API that are being used down below from the C++. But our C++ code makes heavy use of modern C++. As new aspects of the standards come into the compiler, we want to make use of them. And we're quite aggressive on that. And so we evolve our compiler toolchain of the core very rapidly. The public APIs, they don't have that luxury. They've got to use the version of the compiler that Apple say you've got to use to work with this version of iOS. Or the Qt company says that you've got to work with that version of Qt. You don't get to choose your compiler version. And so because we've got that C API in there, we get the binary separation, and we can evolve the tool chains independently. So it allows us to quite rapidly move things along. So we take that C API and we machine generate an interop tier, which the public API teams consume, and they spend their time not designing an API, because the API has been designed down below in the C++ code. They spend their time rehydrating that API in their, if you like, their native form, so it looks and feels like a .NET API or a Qt API, etc. And this allows us to greatly speed up the efficiency on how we build our software. Most of our engineering effort is happening in the darker gray box, that C++ runtime core. These actual API teams, the engineers, there's relatively few engineers on them. Each team has about 4 or 5 engineers will be working on an API team, but there's, probably about 80 engineers working down in the C++ runtime core. So we get the benefits of write the code once and it runs everywhere. So that was a quick introduction to the architecture. Let's have a look at the mapping API changes. And I've kind of talked about this already in the intro there. We really are fully embracing the map as a central component. So where do maps come from? They come from web maps, whether it's a portal on top of your ArcGIS Enterprise, or whether it's a portal on top of our SaaS offering, ArcGIS Online. The portal is going to give us web maps. They can come from Pro in the form of mobile map packages, and they can come from code. Once you've got a map, you can always persist it to disk. All of our objects typically support a to-JSON from JSON persistence mechanism. So you can always snapshot the state of your object graph in a JSON format and then rehydrate it between sessions. So if we have a look at the high-level overview of the API, we have a map view. A map view is responsible for rendering the map. It has one map associated with it. A map can only be in one map view. There's a restriction there. If you try and put a map in 2 views, you'll get an exception thrown within your API. Maps have layers, any number of layers. There's no restriction. There's lots of different types of layers. I've just shown a few of the common ones here, but there's many different layer types. And some of these layers have multiple sort of subtypes, like the feature layer. There's actually various types of feature layer depending on where the features are coming from. Now 3D is actually very similar to 2D, but 3D works with scenes. So 2D works with maps, 3D works with scenes, and it's pretty much the same. You could say, well, scenes come from online, scenes come from Pro, etc. And so the API looks very similar too. So this is our 2D API. To make room for 3D, we'll move it out to the side, and we'll draw the 3D API. It has a scene view, no surprises there, and it has a scene. So that's exactly the same so far as the map. The one place where it deviates from a map is it has a surface. The surface is the reference surface that the scene will relate to. So for instance, if you say drape my content on my scene, it's draping it on that surface. There's one surface that you can have per scene. That surface can have multiple data sources, and we'll automatically choose the most accurate data source for the geographic region that we're looking at that time. If you're a Pro user or a Pro developer, you'll know that Pro supports multiple surfaces. We don't support that. It's not a technical reason. We just feel for the use cases that Runtime is going after, we don't need multiple surfaces. If you've got some valid use cases, then share them with us and we can add that to our requirements. So scenes have layers as well, just like a map. A scene can render anything that a 2D map can have. So if you add a 2D layer to a scene, it'll render and it'll get some basic behavior that's built into the system. If you want to get really 3D behavior and 3D properties, you need to start working with a scene layer. And scene layers are what we use to display 3D specific content. And a scene layer is capable of displaying many different types of 3D content, whether it's in the future point cloud, triangulated meshes, surfaces, buildings, etc. All of these things get rendered through a scene layer. Moving on to the geometry API, we synchronized the geometry API across all the different SDKs. Prior to in 10.2x, they were very different, and we've synchronized that. We made geometries immutable, which was a big change. And actually, they followed the lead of Runtime, and they've got a set of geometry classes which are immutable as well. And we did that because geometries are a basic, fundamental sort of building block of your application. You're always creating them, you're always passing them around, and they get used a lot internally with our engine. And if we know that geometry is never going to change, we can stop checking it because we know it's never going to change. If you want to change a geometry, you've got to give it to a builder, make the modifications on the builder, and then ask the builder for the new geometry. And you get a brand new geometry which you can't change. If you're a .NET developer, this is very similar to strings. Strings are immutable in .NET for exactly the same reason. They're a basic building block. We're able to make performance improvements because of that. We also wanted to accommodate curves in our object model. And so with geometry, we made things immutable. Every geometry has a spatial reference. We have a builder pattern. For simple geometries, types like points, we have a constructor. It's very easy. Envelopes, very easy to construct, just using the constructor. For the more complex types like polyline and polygon, you'll want to use a builder class to add points into your geometry and then ask the builder for the final thing. Exactly the same as .NET developers with strings and string builders. And we also have allowed room, you can see at the bottom here, room for curves. Curves will be coming into the Runtime's geometry model later this year. All right, so that was a very quick tour of some of the main parts of the API and some of the motivation behind the decisions that we've made. I'd like to hand back to David, and he's got the exciting topic of licensing.
All right. Thanks, Ewan. Don't go anywhere, no. So when we re-engineered the Runtime API, we also took the opportunity to take a look at our business model, and specifically our deployment licensing. And there were always some things that I believe we needed to improve on when it came to that. One of them was the definition of the levels. In the old model, we primarily define the levels based on whether you could perform the capability online in a connected fashion or locally offline on the device. And not strictly by capability. And here's what I mean by that. If I was having a conversation with someone and they said, hey, I've got this application, it does editing. What level am I in? I couldn't answer the question without a follow-on question, which was, well, that depends. Are you editing directly against the service? Are you online, connected? Or are you offline? Are you taking data from the service, going offline, editing the data locally, and then syncing back up? Because the latter puts you in a different level. And so what we did was we wanted to be very clear that we wanted these levels here, so we've come up with 4 levels, light, basic, standard, and advanced, are defined more on the capability that you're using, not whether your app is going to go offline because you're not close to a cell tower. So very briefly, let's take a look. The light license level contains a lot of commonly used capabilities found in most apps. Some of the capabilities that are in light now used to be in a paid level before. Light is a no-cost level. We'll get into the actual licensing mechanism in a minute. But light includes, of course, the viewing of maps and scenes and layers. It includes the usage of packages. I say usage because packages aren't just about viewing. If you create a mobile map package in Pro, for example, yes, of course you get the data to view, but you can also author in the ability to route and find addresses, etc. Simple routing. So it doesn't matter if you're performing routing against our service, against a service you might host on premise, or if you're taking a routing network offline and you're doing it locally on the device. Routing is routing, and it's in light. And then in the light level, we support some basic WebGIS capabilities like viewing maps and other items, and participating in groups, either private or public. So you could get an invitation to a group that has some data that's being shared with you, and you can accept that invitation and participate.
So for the engine developers in the room, a lot of engine applications got built, and they were simply viewers of maps offline in a very small, focused application. And that was a significant investment. You had to pay for the license. You can now do all of that for a no-cost deployment with the runtime. So huge business opportunity for developers to take advantage of this light level. And as David said, it doesn't matter whether you're viewing connected maps and layers that are connected to services, or you're actually taking these services offline. As long as you're not editing them, you can do all of that on a light license. So
yeah, and you just illustrated another reason why we changed the model, which was we needed to adapt to more current market conditions, and everybody expects routing. Everybody expects being able to find addresses, and so we wanted to make sure we were current with that. Basic builds upon those capabilities and primarily adds simple feature editing against a feature service. That means point line polys against an editable feature layer that's exposed in a service. It doesn't matter if you're editing directly in an online fashion against the service, or if you've taken data offline, edited it locally on the device, and then syncing back the deltas. It's in this level. Standard builds upon that in that we give you local access to various raster and vector files. What does that mean? It means these files aren't necessarily published through the platform as a service. They may get side-loaded onto a device. They may get emailed to the user. They want to use it in your custom app. And so we provide APIs to allow you to access and, where applicable, edit these files. Also, other tools we offer, editing directly against file geodatabases, some conversion and management tools, and also some analysis tools that involve some of geometric operations like line of sight and viewshed. Also with standard is the optional analysis extension. This has taken our previous 3 extensions, 3D, network, and spatial analyst, and put them into one analysis extension. It's an optional add-on. We still have that same optional add-on for the advanced. The advanced includes all the previous capabilities with additional, more advanced analysis like frequency, near, and split. Also, direct connect to your SDE instances to edit. So that's great. Those are the 4 levels. How do we license them? There are 2 options you have when licensing. One is through a named user. The other is through a deployment license. It's an or, it's not an and. You'll choose one of these options to license your application. So in the case of licensing with a named user, your application will prompt for the named user credentials. They'll be authenticated, and then based on your named user, those levels of, or those capabilities within the API will get lit up. A level 1 or level 2 named user unlocks applications at the light level. A level 2 named user unlocks applications at the basic level. Now, this follows very closely with our ArcGIS Online pattern of what level 1 and level 2 can do. So we try and keep very consistent that way. In order to use a named user with an additional license to light up standard and level capabilities, that's coming by the year's end. Currently, you can use your named user to light up light and basic. When using a license key, these license keys are delivered in a pack of 25 deployments. Or depending on the level, actually, it could be 50, it could be 5. You see how they're broken down here. But you get a license key. And that license key you will use in a set license method call within your application. It'll get compiled, and that's how you will unlock certain capabilities at certain levels. I mentioned before, light is no cost. Once you sign up for the program, you just go to your dashboard, you can generate a light license key and burn it into your app and use it. We are right up against the hour. I think we should take one or two questions, if there are. One or two questions. Are there any questions? Yes, sir.
I have a really quick question about the licensing.
Sure.
Level 1 and level 2 users, does that only apply to ArcGIS Online, level 1 and level 2 users, or does that also apply to level 1 and 2 portal users?
Yeah, so yeah, sorry, yeah, yeah, I'll just repeat the question. The question is, I wanted to get to it so fast because I didn't want to forget what it was. The question was, that level 1 and level 2 user, does that include both the users you get on premise through ArcGIS Enterprise as well as the users online? Yes, it does. Yeah. Is there another question? Yes, sir.
ArcGIS Pro SDK tool is on top of the common core
The question is the ArcGIS Pro SDK, or probably correctly say, is the ArcGIS Pro application built on top of a Runtime core? Yes, but it's also built on top of other things too. So ArcGIS Pro's architecture actually takes the heart of the Arc objects, the data access tier, etc., from ArcMap and ArcGIS Desktop and ArcGIS Server, and it moves that into Pro. But it also pulls in ArcGIS Runtime's C++ core for doing certain things, like the new geocoding or geometry engine gets used. There's various aspects, and the Pro application team, they pick which one that they want to use. But their architecture, they have these independent engines now. Sitting on top of that, they have an internal services tier. Sitting on top of that, they have their Pro SDK. And so, unlike ArcMap, where the Arc objects that we built the system with was the same API that you use to customize it, in Pro it's a little bit different. We separate the public API from the internal engine so we can evolve the internal engine. So although it does make use of runtime and it makes use of Arc objects, this is Pro, you're not really aware of that. You just get access to functionality.
One more question, yes.
So the question was, with the latest version of the runtime, I said we can create maps inside of code, and the question was, can we do that with scenes as well? Absolutely, yes.
Thank you for joining us this morning. I know it was early. Enjoy the rest of the day, and we'll see you at the little get-together this evening.
Thank you.